of positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 6. So we had one variation in f of x giving us one positive root. We had two variations in f of negative x giving us 2 or 0 negative roots. And now we have a bunch of possibilities. Now, because we have one positive, you might want to start out by trying some negatives, because we know that there can be two of those. So let's try a negative 1, just so we're trying something different. We have 1, 2, negative 3, and negative 6 synthetic division. Bring down the 1. 1 times negative 1 is negative 1. 2 and negative 1 is 1. 1 times negative 1 is negative 1, and negative 3 is negative 4. Negative 4 and negative 1 is positive 4, and we get a negative 2. And this one did not work. Negative 1 does not work. Let's try negative 2 as a possible root. 1, 2, negative 3, negative 6. Bring down the 1. 1 times negative 2 is negative 2. 2 and negative 2 is 0. Negative 2 times 0. Negative 3 and 0 is negative 3. Negative 2 and negative 3 is positive 6. Does give us a remainder of 0. So therefore, I know that negative 2 is a solution. Now when I look at this bottom line here, because this was x to the third, this is going to be an x squared minus 3. And when I set that equal to 0, I get x squared equals positive 3. X equals positive and negative square root of 3 for the other two solutions. So we have a change of positive to negative, and then we have no other changes. So we're going to have one positive root. Then we take f of negative x. Negative x to the fourth power is going to remain x to the fourth. Negative times itself 3 times is going to be a negative, times the negative there is going to change this to a positive x to the third. Negative x to an even power is still going to be positive, so this is going to be a negative 5x squared. Negative x times negative x is positive x minus 6. We have a change from positive to negative, a change from negative to positive, a change from positive to negative. We have 3 changes here. So I have 3 and 3 minus 2, subtracting an even number. We can have 3 or 1 negative root. Now we're looking for the possible rational roots. So I want to take the factors of the constant, positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 6, the factors of the leading coefficient, positive and negative 1. So we can get positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 6. And with synthetic division, you can try many of them. We know one is going to be positive, but we know that there's going to be more negative ones. So we can try 1, 2, 3, 6. Or we could try negative 1, negative 2, negative 3, negative 6. And again, it's trial and error. And so you can hit on it right away, or it might take you a while to try it. I'm going to hit on it right away here. So I have 3, and I'm using 1, negative 1, negative 5, negative 1, and negative 6 as the coefficients. Bring down the 1. 1 times 3 is 3. 3 and negative 1 is 2. 2 times 3 is 6. 6 and negative 5 is 1. 1 times 3 is 3. A negative 1 and 3 is 2. And 3 times 2 is 6. And we do get a remainder of 0. Therefore, I know 3 is a positive root. Now what I have, if I'm looking at this bottom line here, I have an x cubed plus 2x squared plus x plus 2. I now have a different polynomial, and I can repeat the process again. There are no changes here. So for f of x, I know that there aren't any positive roots left. And I'm going to take a look at the factors, positive and negative 2 over positive and negative 1. I know I can have positive and negative 1, positive negative 2 to try now with synthetic division. So I might as well just try the negatives. Try negative 1. I have 3, 2, 1, and 2. 1, 2, 1, 2. So bring down the 1. 1 times negative 1 is negative 1. Negative 1 and 2 is 1. Multiply is negative 1, 0, 0 here, and this is not a solution. If I try negative 2, then I have 1, 2, 1, 2. Negative 2, it's going to give me 0, 0 here, 1, negative 2, and negative 2 is a root. And now what I have here is now x squared plus 1. X squared equals negative 1, and I know that I have 2 roots that are imaginary here because I ended up with a square root of negative 1.